Hi, everyone. Kate Meredith here from Glass Education, and I am happy to be hosting the SonNet and Sonification World Chat today. It is great to be in southern Wisconsin. I've been spending my summer up north, and I could share a lot of sunset pictures with you. It's been a great summer for me, but it's good to be back down here where the internet's a little more reliable, so we can have a chance to talk today and make some progress on our project and hear from Robert Alexander today. I put the link to the agenda is in the chat, and you can go there and type your own name in and your affiliation. Otherwise, if you don't get there today, I will go grab that. Our agenda here at the World Chat is sort of an open forum for typing in things that you want. I'll clean it up after we're done. And so if you have any other announcements or links to share, go ahead and put those in under updates from the community. That's under the agenda. And we'll be making sure that we share those. So we're going to start with some introductions. And today we have a very long agenda today, but we are going to push a big chunk of that agenda into another meeting because Robert has been doing some work and he has a lot to share with us, and he's really excited today. So we're going to just allow him to have the space and time to do what he needs to do and generate some discussion. And then at the end, I'll wrap up and see what kind of time space we have left, because we want to start launching some fundraising, fund development end of this project, because we are coming up on the end of our first year, and it's time to figure out what kind of projects this community wants to generate. So with that said, yes, I'm Kate Meredith. I'm from Geneva Lake Astrophysics and STEAM, more lovingly called Glass Education. We are in southern Wisconsin. We mostly do disability access and STEM education outreach and career development. But we got into sonification a number of years ago. I'm not an expert in anything, can't code my way out of a box, but I am the happy den mother of data sonification. I like to make sure everyone gets together and has what they need in order to let their creative juices flow, and make sure that this effort of data sonification remains something that uses the lived experience of people with blindness and low vision, because that's how this will make its biggest impact and contribution on the world, is through including that community. And sometimes that's hard to do. So I want to make sure that all the musicians and all the BVI professionals and cultural diversity, cultural people, neuro, psych people, all get a voice in this so that we can build the best sonifications we can. So that is me. And also on this project is Matt Henry. Go ahead and give us your introduction.
Hi, I'm Matt Henry, and I work with the evaluations firm, the Everett Group. 30-year musician prior to that in different capacities. Am fascinated with science and all of this. Glad to be a part of it, and hopefully can help. And I'm coming to you from Columbus, Ohio.
Okay, coming to us from the other side of the room is Mari Lucero, and she is a student at UW-Madison, also been on with our sonification project since she was a baby astronomer. So Mari, go ahead and introduce yourself.
Hello, can you hear me okay?
No.
Nope, I guess that's not going to happen. You're kind of frozen. So yes, I guess the office is only going to support me today, which is, at least it's supporting me. So go ahead. Tim, I'm going to let you introduce yourself.
Me?
Yes, you.
Wow. I wasn't expecting to do so, but my name is Tim Larson. I am a global helioseismologist. Got my PhD at Stanford in 2016, I guess. Wow, so long ago. And since I left there, so I don't have any like formal affiliation. I'm talking to you now from a corner of my mom's dining room. But since I've been away from Stanford, I've put a lot of work into, so basically I study sound waves inside the sun, And you tell somebody that, and the first thing they want to ask is, "Oh, wow, it's so amazing. What does it sound like?" And so I spent about 10 years being like, "Oh, ho hum, we never really listened to it." And so anyway, the year after I left Stanford, actually, my collaborator Seth Schaefer, I think, is on this chat too. But he turned me on to this um, pure data visual programming language, and so I spent a lot of time like making this free software so people could like listen to the data that we use for global helioseismology. And so anyway, that's why I'm extremely interested in what you guys are doing. And like I said, I only just got this email. I don't even know how it came across the list, but so I knew nothing about it except that it's about sonifying solar data. And so here I am. And after this talk, I'm glad to share with you what I've done. I'm super interested to find out what
Good.
you've done. So
There'll be lots of time for discussion. A longtime member of the World Chat, one of the founders, Fia, go ahead and introduce yourself.
Hi. So I'm here on the Gold Coast in Queensland, Australia, where it's just after 6 a.m. I'm the co-founder and director of SonoKids Australia, which is a developer. We are developers of educational game apps that are fully accessible for students who are blind or have low vision, and teach them technology and digital skills, including sonification with our latest app called Cosmoboli on Sono Planet, which, while it has a planet name in it, is also just a generic kind of sonification introduction for everyone. I've recently passed on the baton of the presidency of SPEVI, South Pacific Educators in Vision Impairment, which is the organization for all the specialist teachers here in Australia, New Zealand, and the South Pacific region. Very much involved with sonification, and also the Learn group of our Sonification World Chat. And I think we have that on the agenda, so we'll talk about that later. Lovely to see so many new people here.
All right, and fearless leader of GeoSonNet, the NSF project, Amy Bauer.
Hi, Amy Bauer. I'm a senior scientist at Woodsole Oceanographic Institution, physical oceanographer who's blind. Been working with Kate on the GeoSonNet project and dabbling in sonification myself. And we don't do just solar sonifications, Tim. Anyway, that's it for me.
Okay, we're working on all the geosciences.
We are.
And of course, astronomy. All right, Anna, Amy's sidekick.
Hi, yeah, I'm a research assistant and access assistant with Amy Bauer here at WHOI. And yeah, just trying to figure out how to use sonification to make data more accessible.
Okay, thanks, Anna. Next, we're going down the list. Please correct my pronunciation of your name, Evaldis.
Hi, sorry, I wasn't aware I was going to talk, but I worked with Robert on the HART project and told me about this. So I just came to see what he's going to talk about. Make fun of him later.
Okay.
All right, thanks.
Well, we're glad to have you. We try and get everyone to introduce themselves because this is a community that interesting connections have always been made, and at least a third of our participants are not sighted. So getting some voices attached to who's on the call is always really helpful. Seth, you're up next.
Hey, folks. My name is Seth Schaefer. Like Tim Larson said earlier, he and I have worked for several years on a project to sonify the sun using kind of long-term solar data. My background is as a musician, composer, and I'm affiliated with Cal State San Marcos. And yeah, I just heard about this morning from Tim, so I'm really excited to hear about your project.
Thank you. Wei Jin?
Hey, I'm Wei Jin. I'm a groundwater modeler. I just got an email about this, and I just want to see what I can learn from this.
Thank you. And Zuling Chi?
Oh yeah, just similar with about this. Just learned this from Robert. I've been working with Robert and Mike and Avedis on another project. I'm a research assistant professor from Virginia Tech.
Okay, thank you very much for being here. Janine. And Janine is not responding, so I'm going to move up to Adrian.
Hello, hi, I'm Adrian Provenzano. I am a STEAM educator and musician. I connect the arts and humanities with STEM in many different ways. I've been affiliated as a volunteer with NASA's Solar System Ambassadors Outreach Program for more than a decade now, which is one of my platforms for sharing Earth and space science information. So I'm especially interested in the sun as a solar system ambassador. Let's see. I also wanted to mention that I'm also an interpretive naturalist, and I'm currently working on a project about education and biomimicry, not specifically sonification, but also interested in multimodal, multisensory, formal, informal education and outreach. So I'm going to see if I can tie some sonification into that presentation, or certainly the idea of sound and education and outreach. So it's nice to see nice to see and hear new people on the call, as well as a lot of the regulars.
Thanks, Adrian. Cheryl.
Hi, everyone. My name is Cheryl Fogle-Hatch. I'm a museum accessibility researcher and consultant based here in Baltimore, Maryland. I help with producing tactile and audio components for exhibits.
Okay. Michael, I don't think I got you.
Yeah, I'm Mike Hartinger at Space Science Institute, research scientist based in Los Angeles, and I work a lot with Robert, and he reminded me of this meeting, but I remember meeting you at AGU, Kate, and have been meaning to come to this meeting for many months now, and I will hope to come more from now on. And I'm very excited to learn more about all the different activities happening all around sonification.
That's right. We met at the obscure coffee shop that was most excellent and worth the effort. So, which is also where I got to talk to Robert for the first time. One more person has chimed in, Argyros.
Hello, hello. I met many of you in Notable Universe, right? Like 1 and 2.
Yes.
I'm Argyros. I'm blind. I also did a PhD in solar physics. Now I'm currently working in Deutsche Bank as a data scientist. It's a long time since I signed in the meeting, but now that I have figured out some stuff in my life, I hope I can be a more frequent visitor here.
I am really glad to see you back on the Sonification World Chat. And yes, it was great meeting you at Audible Universe and staying connected. It's been good. So with that, I believe that we have introduced everybody, and now we're on to the main event. We will circle back to other community announcements when we are done hearing from Robert. And I have introduced Robert before because I was really excited to meet him, and he has done some very interesting work. I'm personally always plugging the Breathscape app on the phone. It is an anxiety management tool that I find just lovely. It translates your breath into music as you use it, and it's really fun. So, but he's done so much more. He's deep into the science, and he's going to teach us looking at this world of sound through the audification lens today. And we tend to here at the World Chat adopting the focus on the data sonification, which is the translation of data into sound. And we tend to have that. We've done a lot of things with music, with the musical end of things, with the educational end. So we encompass everything, even though our grant has a particular focus on it. And today I'm just really excited to hear about Robert's work and see what kind of questions and partnerships that may generate. So Robert, thanks for coming today.
It's great to be here. And audification is also a type of data sonification. The more musically oriented or parameter mapped approach is the umbrella of parameter mapping. And I'll get into that in my talk. But yeah, audification is the direct isomorphic one-to-one mapping of data samples to audio samples. So I can go ahead and share my screen once everything is up and ready. Share button. And
You got it.
Escape. I think we are all set. Let me actually shift my own audio really quick because I'm listening over the speakers and I want to be listening over my headphones. Okay. Thank you for your patience. Take
And I
two.
believe we have 3 people on today who are screen reader exclusive users. So yeah, just make sure we describe all the things that you've got up.
Perfect. Hello, everyone. It's exciting to be here. I've been looking forward to this talk for a long time. The title is Ears to the Sun, Revealing Hidden Structures Through Data Audification. And I'm not sure how many people are familiar with a little show called The Magic School Bus. If people are on video, then it's helpful to like see hands and that kind of stuff. And I was thinking, what do I want to do with this talk? And I realized, I kind of actually just want to have more of an adventure today. So I'm thinking of this as a bit like a magic spaceship that we can all ride on together. You can see here I've worked closely with Dr. Jayvern Yarrow at NASA Goddard Space Flight Center for the last couple of years. Before that, I was working at Goddard as a part of my PhD with a dissertation in data audification for the exploratory analysis of heliospheric data sets. It's a big mouthful. And now I'm also sponsored through the PHASER program with University of Maryland, Baltimore County. But before I get too far ahead of myself here, I want to give you my real credentials. I want to give you the important credentials. Important credentials are that I love sound. I am a human being who grew up, this is one of my earliest memories. I'm sitting in a car seat and playing my harmonica. And I remember the first song that I ever wrote was I would just kind of blow up on it, and then I'd blow down, and then up, and then down. And at the very end, I would go up, but I would go up really slowly. And that was the innovation that I brought to the harmonica, which maybe predates Breathscape a little bit because it's turning breath into music. But really, everything that you're going to see today is coming from that place of just really love. I have a deep appreciation for the world of sound. I'm a producer and composer. I've always been very curious, and I used to love throwing rocks into the air conditioner unit at my home just to hear what they would sound like as they kind of exploded and sparked. Didn't understand why my parents didn't like that very much. But this is where everything truly began, and also just grateful for my parents and good parenting as well, and all my peers around me. Without any further ado, I've talked about audification a little bit. I talked about it as an isomorphic mapping. I want to play one of my favorite little videos that I put together as a part of my dissertation that walks through the audification process. So here we go. A lot of people ask me, what is data audification? Or what's a multimedia artist doing working with NASA? I was approached by the Solar and Heliospheric Research Group at the University of Michigan with a challenge. Use audio to help us learn something new about the solar wind, which is holding a sun on the screen, particles that's constantly flowing outward from the sun. You see, there are all these satellites out there constantly gathering observations, and we have more data than we know what to do with. We traditionally analyze this information through plots and graphs, which are essentially squiggly lines that we can read to determine speed and temperature and other various parameters. It's possible to translate these squiggly lines directly into audio files and play them back over speakers or headphones. Imagine that we cut this line into a groove on a record. Through this process, 44,100 data samples get compressed into a single second of audio. When we listen closely to the frequency spectrum of the audio file, we found that sometimes we're able to hear things that were previously overlooked. Now, most solar wind turbulence sounds like wind hitting a microphone, which is not all that interesting. But sometimes the interactions between waves and particles sound like chirping birds. And occasionally we'll hear a whistling sound. Recently, we pored over millions of data points and found something fascinating. You see, the sun released an explosive cloud of particles, and when we listened closely, we heard a unique whooshing sound. I passed the data to a scientist and they crunched the numbers. It turns out this feature is an ion cyclotron wavestorm unlike any that has been seen before. And we're finding that researchers can identify new features like these with very little training. from auditory observation to new scientific insight. That's how audification works. I want to pause right here because another way of thinking about the process is opposed or kind of aligned with parameter mapping is that when we are doing a parameter mapping, we're thinking about how might we map data onto musical parameters. And so you could be taking the cutoff frequency of a bandpass filter and then taking the speed of the solar wind and using that to drive that cutoff frequency. And you might get some whoosh, kind of whooshing up and down sound out of that. You could also map a sound to a musical chord, a musical texture, a musical scale. So there are a lot of decisions that can go into the parameter mapping process. With data audification, the process of writing the audio file is very straightforward. And then there's a lot of decisions that we get to make on the flip side when it comes to actually playing back that audio, because now we have all the same tools that a DJ could use and have at their disposal. Filtering, EQing, things of that nature. And it turns out that things like filtering are also things that scientists do on a regular basis. So let's jump into a sonic example. Now this is a nightingale on the screen. So we're not listening to sonified data. The definition is non-speech information. But this is a bird call here. And this is just an example of how when we transform things with sound, it can transform our perspective and our understanding. So let's go ahead and listen to this bird. And as we slow it down, suddenly we start to think about the relationship that birds have to dinosaurs, because suddenly, rather than this kind of little small nightingale sitting on the bench there, what we're perceiving is this kind of almost a large beast, just because now we're slowing down the rate of sample playback to about maybe a 10% or 20% of the original playback speed. And suddenly we're able to appreciate the sound in an entirely different way. Sounds like some kind of strange dinosaur in an ancient forest, right? Now, we can also take a step back and take a look at our planet from a new perspective. We're able to sonify things like seismic activity. This is the Tohoku earthquake in Japan, 2011, and we're about to hear that seismic event now. So through the process of data audification, of mapping each data sample to an audio sample, now this earthquake, it takes on this acoustic property if we listen closely. Because they are indeed acoustic events. What we're listening to here are the impulses of energy as the crust or the mantle and all these various layers kind of fracture and rupture, sending energy out through the crust of the earth, and now it's resonating like a drumhead, like a membrane. And as we're audifying, we can now filter that information. So now we're just listening to the low end. We've low pass filtered. Or if we just listen to the high frequencies, now suddenly it sounds like little bits of hail falling on the roof of a car or something like that. Each time that we change the playback speed, that we change how we're filtering the information, we can come to appreciate a different aspect of that sound. Please fasten your seatbelt. We will be departing in T-minus 30 seconds. Oh, that was a computer voice. I forgot to say, there's a collaborator on this. I'm working with a computer, so I don't know. Do you want to introduce yourself, computer? Hello. Okay, I guess it's not very talkative. So now that we've kind of taken a step back, thought about planet Earth in a slightly different way, let's now take ourselves out into space and with a new perspective, turn our eyes toward the sun.
3, 2, 1, 0, 0.
If you listen closely, you might hear some dawn chorus. The Earth's magnetic field creates this electromagnetic oscillation as electrons spiral along field lines. And this phenomenon is strongest at dawn, which is why it has the name dawn chorus. This is measurements from the MMS SCM, Search Coil Magnetometer. And so we are literally recording our planet singing here. It's a bit of Earth's goodbye song as we launch into space. And I want to begin this exploration where I actually began my research, with the first thing that I audified. So I'd never audified before, and I took some solar data and took each individual data sample, wrote it to an audio sample, and I heard something very fascinating. The audio here is solar wind velocity data from the ACE satellite from 1998 to 2010. And on screen, we have a video of the NASA SDO recording channel 304 angstroms of the solar chromosphere. And what we're listening to is an underlying hum generated by the 27-day rotational period of the sun. And the solar magnetic field actually rings with these spherical harmonics, and I can explain a little bit more of that now. Now on screen, we're seeing this sort of mathematical representation of the solar magnetic field, and we can see one side red, one side blue. If each of the red events is a single feature on the surface of the sun, then we're looking at either one feature that rotates around every 27 days, or two features that rotate around roughly every 13.5 days. Now 3 features every 9 days, creating higher harmonics. And now we're hearing even higher harmonics. And this is nothing added to the data. These harmonics naturally ring in the solar data set. And here we're actually listening to about 45 years worth of recordings from the Advanced Composition Explorer satellite. This is Omni data, but this graph that you see here is from a paper with Dr. Enrico Landi from the University of Michigan Solar Heliospheric Research Group, where we were able to actually take the abundance, the presence of these solar spherical harmonics in different charge states, oxygen, carbon, to actually show that carbon had a stronger harmonic presence, which helped us to better identify the source regions of the solar wind. Now, when that energy arrives at planet Earth, very fascinating things can happen. Let's take a look at a solar flare event. So on March 7th, the sun unleashed an X5 class solar flare, and high energy particles collided with the SOHO spacecraft. On March 7th, the shockwave reaches the Messenger satellite in orbit around Mercury. So we're hearing the particles colliding with the FIPS instrument. And this is a time-stretched audification there, which we're matching with a spectral sonification of the visual field. That was from the SOHO spacecraft. Now we'll listen to both at the same time. Now, as this energy flies out into space, flows along those magnetic field lines, very fascinating things happen as it arrives at Earth. Just earlier today, I was meeting with the HARP team, of which I'm a member. Dr. Michael Hartinger is here on this call with us today. He is the PI for the HARP project. And I want to just play a video that's going to talk a little bit about what happens when energy is interacting with the Earth's magnetic field lines.
What is space actually made of? Well, it's certainly not empty. Our sun blows a supersonic wind outward in all directions, blasting Earth and the entire solar system with streams of charged particles called plasmas. Just like wind in storms on Earth, space weather consists of solar wind and magnetic storms erupting from the sun. When these invisible plasmas approach our planet, Earth's magnetic field acts like a protective bubble, mostly pushing the particles out of the way. This bubble, called our magnetosphere, doesn't ever stand still. It's always moving and changing, and can vibrate in wave-like motions in response to the solar wind, like a plucked magnetic harp string. Some plasma vibrations can even power the beautiful aurora, or northern and southern lights. They are the visible evidence that Earth's magnetic field is interacting with plasma from the sun. When plasmas move, their magnetic fields can be measured by satellites and converted into sound, a process known as audification. Now, you too can listen to the sounds of space and help scientists discover new vibrations. Join the HARP Citizen Science Project and engage in totally new space research using real magnetic data from the NASA Themis satellite converted into sound. Use our new web app to reveal the hidden depths and structure of space.
And you'll notice that the sounds from the HARP mission, from the HARP project, are interwoven with the music here in the voiceover.
Similar to how sonar is used to probe the depths of the oceans. We need your help to explore this wealth of satellite data. There's too much for us to do alone. Many kinds of vibrations can occur simultaneously in the magnetosphere, so it's difficult to use computer algorithms or just our eyes to find complex or faint patterns. It's like trying to pick out a single instrument in a tuning orchestra. Anyone and everyone can listen to space and submit their findings. Using HARP, you might even find something no one has ever heard or seen before. Check out HARP, Heliophysics Audified.
Resonances in plasmas. So next, I just want to show you guys the interface from this project. Avaldis, who is here on the call with us today, coded this up, I believe, in Unity, and thousands of people have logged in and have cataloged various events and features. If you think, as that video said, of the Earth's magnetic field as like giant harp strings, you can see on the lower plots there of the frequency spectrum, these kind of hoops that are going down and then back up, down and back up. Now, as we're closer to the Earth's poles and the field lines are shorter, we're getting these kind of shorter wavelengths. And then as we move out and out along longer field lines, I might have gotten that backwards, the field lines are longer, and that results in varying frequency. And usually it goes from high to low to high. But the participants in the HARP Citizen Science Project actually uncovered an instance in which the frequency goes in the inverse, kind of going from low to high. And so part of the conversation earlier today was just excitement around now being able to publish those results. And we're looking to submit that in the next coming months. So let's just go ahead and play back some examples here. And here we see an individual selecting a region. They were able to submit what direction the frequency is moving in, their level of confidence, along with general observations.
Attention.
What is this?
Anomaly detected. Anomaly detected.
Sorry guys. Cancel alarm. What's going on?
Increased solar activity.
Oh. Okay, let's check it out. Can we bring that on screen?
On screen now.
Huh. Okay, so wait, this is what we detected?
Confirmed.
Okay, so wow, this is actually, so we're kind of like in a time machine here or something, because this is the Mother's Day CME from 2024. And what makes this anomaly worth pointing out is that when this arrived at Earth, it was the largest CME that we've had in like a couple decades, and it caused these giant Kelvin-Helmholtz waves at the boundary layer. If we think about driving in a car and you've had the experience of rolling down one window and it causes it to go, and so you either roll down another window or you roll it back up, that's a sort of Kelvin-Helmholtz instability where you get that fluttering happening. So what Katerina Nakiri, who is project scientist for MMS, discovered was that here, actually, there was this KH instability as the CME arrived and just went, the energy was whipping around the planet Earth. So we're going to listen for that. We're also going to see the averaged amplitude down at the bottom. So we're looking for fluctuations, and we're listening to that here as well. So we got like a whoop, 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 whoop. I'm actually just going to play that one again. I'll slow it down just a little bit. And it sounds very noisy because we're dealing with very turbulent and chaotic events. There's a whole influx of energy there. And next, I think I would actually like to trace the energy lines up a little bit. So if we were to observe, let's say, the MMS satellite, maybe we could set a course for the MMS cluster.
On screen now.
Okay. What we're observing here is the MMS tetrahedron formation, and what we're actually going to be able to witness is what's known as a reconnection event. So sometimes as the solar wind is flowing from the sun to the earth, we get these moments where magnetic field lines, they kind of like disconnect and reconnect with one another, and it releases this huge amount of energy. And what we're believing is that this can be a source of just tremendous amounts of energy that's driving the outflow of the solar wind. And so this is kind of what I want to investigate with you guys here today, is kind of where is all this energy coming from that's coming from the sun? And I want to take us up closer to the sun. But first, let's have a listen to what MMS identified. I know Christina Collins was on the call just a little bit earlier. I can't see if she's still on now, but she's a co-author here on this paper. She's the lead author on this paper, where we took this MMS tetrahedron formation and then did a binaural modification such that it's as though you're sitting in the middle with your head in the center of this diamond, and you've got the spacecraft located around you. So it's a binaural recording, and let's go ahead and listen to that now. So we've got these high frequency wave events occur as the electron density, current density goes up. And we can pay particular attention in the lower right corner to the current density and then the audio spectrum in the lower left corner. So I like to believe that with the pursuit of science, just kind of as an aim and as a goal, we human beings were wanting to know our universe and our world more deeply. And so we create things like satellites to be able to extend our senses. We're not able to perceive visually certain aspects, certain frequency bandwidths of the electromagnetic spectrum, but what we can do is we can translate those into visuals through false color imaging. We can translate that into sound through audification, through parameter mapping. And that allows us to get a little closer to that ability of actually just kind of taking in everything, to be able to sit and float above Earth and to bask in the solar wind. And I, for one, would certainly love... Wait, what is this?
Attention. Anomaly detected.
Okay.
Anomaly detected.
Sorry, we got another cancel alarm. What's going on?
We are approaching the magnetic bow shock of planet Jupiter.
Okay, so we're moving closer to the sun now. Let's bring it up on screen. Fascinating. So is this what we identified?
Confirmed.
Got it. So this is actually a recording of the Voyager 1 spacecraft as it was approaching Jupiter's magnetic field. If you've ever been in something like a boat and you notice up on the bow as it's slicing through the water, just waves build up, it's what causes a sonic boom from a jet. You just get these standing waves out in front of the boat, the ship, the craft, and then that ends up going all the way out to the shore. But right out in front of the ship, there's this massive collection of energy, and you can just think of how much energy a planet would make as it's moving out through interplanetary space. It's being swept up with the solar wind. And it's actually a planetary bow shock. So what we're listening to here is the Voyager 1 spacecraft as it's colliding with Jupiter's bow shock. That on its own, I just absolutely love that sound. You'll notice that there's a horizontal line going through part of the frequency spectrum. Oftentimes there can be things like tone induced by the instrument or spin noise. So oftentimes before sharing things with the public, we'll just do a little bit of cleaning. We'll remove certain types of noise if they're instrumentally induced, spin tone. So that's what's going on there. Also, the spectrum on the right, you can see, is quite a bit more complicated. On screen, I've got the frequency spectrum that we just listened to of that event of arriving at Jupiter, the magnetic bow shock. And on the right, we're about to listen to some music because this is an infusion of that sound into, it's the forthcoming album from the artist Frankie Jupiter. And so this is a kind of little play on like Jupiter arriving at Jupiter. Frankie Jupiter, what if he could be floating out in space and fall into the planet Jupiter over the course of the album? So I always love to mix the data and the art and the science. And so let's just go ahead and listen to this now.
I was saying I could break the spell, broke my promises instead. Razor edges in a wet hotel. I was busy playing dead, but it's
So it was right there, right as the drums were about to doof, doof, doof. We got the, and it's still kind of rumbling in the background right here. And from here, I mean, we're still tracing that energy back up to the sun. So I actually think if we could set a course for the heliospheric current sheet, so this is the largest object in the solar system, if we were able to listen to that, it might help us better understand reconnection. So can we set a course for the heliospheric current sheet?
Setting course.
Oh, nice. All right, can we bring that on screen now?
On screen now.
Perfect. So what we're looking at here on the screen is a series of plots. We're looking at the pitch angle of electrons. We're looking at the proton power distribution spectrum. We're also looking at the velocity of a solar wind as well as the magnetic field. And then up top, we're looking at what are known as VDFs, velocity distribution functions. They're telling us a little bit more about the distribution of the energy in these protons. What we're going to listen to here is the magnetic field as we cross across the heliospheric current sheet. And we're going to listen upstream before we've arrived, and then we're going to be inside of it, and we're going to hear a different kind of turbulence. And then downstream, we actually have some mystery waves. And audification can help us to listen to some subtle details, like, is this feature, is this event, is there some flapping that's happening? We can listen closely to detect new aspects and subtle new features. It's one of my favorite sounds. I almost didn't want to pause it to talk over it, but right there we can imagine. So the heliospheric current sheet is the magnetic neutral line that extends outward from the sun. The sun has the poles, the north and the south pole. The poles, they reverse, and this results in the solar cycle in which we have solar minimum, solar maximum. Recently, in the last couple of years, we've been hearing more about solar activity. So we've been in solar maximum. We're going to be moving towards solar minimum. But this...
Attention.
Oh my
Anomaly
God.
detected.
Guys.
Anomaly detected.
Cancel alarm. It's just
The alarm itself is kind of annoying.
I'm sorry.
Oh, sorry. I feel like I hurt its feelings. Okay, what did we detect this time?
Increased solar activity.
Interesting. Can we bring that on screen?
On screen now.
Okay, so what we're actually looking at here, we've got the Whisper instrument that's giving us a visual field as we're actually getting very close to the sun now. This is with the Parker Solar Probe. It has all these times it's going around and around the sun. We're at encounter, we just had encounter 24, which is successful. The data hasn't come down yet, but this is encounter 13. And Orlando Romeo et al. Produced this really beautiful paper about this coronal mass ejection, where the spacecraft gets within about 13, 14 solar radii, and then gets blasted by a CME, coronal mass ejection, which is this huge release of particles, which can happen when magnetic field lines get twisted up. Imagine like twisting a balloon. Eventually, it's just a bunch of pressure. It has to kind of snap and break somewhere, so it just kind of pops off and into space. So this now is this very close encounter with the CME. I mean, I personally am amazed that the spacecraft survived this, because 13 solar radii, if you think of like, my fist as the width of the sun, it's just like 13 of that, and the spacecraft gets that close and is hit directly. So let's just go ahead and experience that now. This is absolutely my favorite. We need to watch this one again. So we're actually here listening to a variety of instrument types. Mostly we're listening to the solar magnetic field, but during the moment of the explosion, we switch and we're superimposing the electric field, which has a higher sampling cadence, which allows us to get some of the more like kind of deepy bass kind of stuff, and we're getting more of the high frequencies as well. So it's almost like the Matrix bullet time. At the moment of the explosion, we're slowing down time. And this is encounter 13. We're now up at encounter 24, but actually the last publicly available data that we have is from encounter 23. So I'm curious, could we somehow like have a time machine just bring us to encounter 23?
Confirmed.
Nice. So set a course for perihelion encounter 23.
Setting course.
All right. So what we're going to listen to now, I have goosebumps already, because we as human beings, we have this thing that's called research, science, the scientific method. And again, we're bringing the universe closer to ourselves. We're wanting to understand, how do plants grow? How do seasons change? How do the tides move? Eventually we get to the point of wanting to understand the source of the energy in the nearest neighboring star, which is a proxy for all stars. We want to understand energy transport in the universe. And this recording that I'm about to play is the closest recording that human beings have made of any star. And I've taken two components of Parker Solar Probe's magnetic field, the tangential and the normal, and I've panned the T to the left and N to the right. And for this example, I just wanted to kind of give it as pure as possible, so I'm not doing any processing. Just think of this one as like a meditation. It's going to be rough, and it's going to be rough because this is the closest we've ever gotten to a star. So, how are we doing?
Parker Solar Probe is now approaching perihelion.
Okay, let's go ahead and bring that up. Without any further ado, let's go ahead and touch a star. Just settle in. Feel free to close your eyes or really just sink in the sound.
So we just crossed over perihelion there. I really love to just kind of meditate on that one. It is a wild and turbulent and chaotic sound, but also knowing what that sound represents is something really profound, just in terms of what we human beings are capable of and what we've achieved with that recording. And we're able to perceive and measure multiple layers of the sun. Here with the Parker Solar Probe, we're working with high resolution magnetometers. And so we're measuring the sun's magnetic field and transferring that directly to audio files. So the magnetic field is recorded about 292 samples per second here. There are other approaches that we can take. And I want to show something that's kind of right on the leading edge of what I'm up to right now. And this is working with the Solar Dynamics Observatory and doing spectral audification. So that is audification of each of the different layers of the each of the different angstrom wavelengths, whereby we're able to listen to different wavelengths of the sun and then have them crossfade through one another. So let's go ahead and bring that up on screen.
On screen now.
All right, so we're seeing the sun in the middle right here. And then on the edge, on the left and right edges, we've got these bars that are the spectrum, because we're taking the visual and then we're decomposing that into frequency. So you can think of it as like a pass-through that's enabling different aspects of audified data to pass through. And what this enables is that as a feature rotates around the surface of the sun, when it's on the left, the kind of left frequency gates open, the data pours through. As it rotates around to the right, then slowly we can hear it auditorily shift. And what this enables is for us to hear features rotating across the surface of the sun. And not just that, it enables us to hear across multiple layers. And this recording that we're listening to now has somewhere around 200 different channels of audio with all of the sort of FFT and the convolution that's involved with creating all of these distinct audio channels. So I'll go ahead and play this now. So there are so many different ways to visualize information, so many different ways to listen to information. And myself being a multimedia artist, as well as a scientist, researcher, and just curious human being, I love to take the opportunities to take all of these sounds that I work with and to just kind of create like a little treasure chest of all my favorites. And I recently had this opportunity to work with this artist, Jake, as well as Alex Metric. And there's a song called Golden Hour, and had the opportunity to release a track where the drums, the synths, everything is derived from the solar data. So let's go ahead and bring that up on screen.
On screen now.
So what we're going to experience here is a song maybe you've heard before, but now we're starting to blur that edge with science.
You've seen the sun a million times, but have you ever listened to it?
So this was commissioned by Magnum Ice Cream. We premiered this at the Cannes Film Festival. The piano obviously is not solar data. The voice is not solar data, but pretty much everything else is.
Sitting in the car, listening to Blonde, falling for each other. Thinking orange skies, feeling super childish, no Donald Glover. Missed call from my mother, like where you at tonight? Got no alibi. I was all alone with the love of my life.
So that kick drum, magnetic field, solar magnetic field.
In my radiant beam in the night, I don't need no light to see you shine.
That snare again is just a little resonant sort of thud event that we got with some waves. Those high frequencies, the kind of sizzling sounds, again, ion cyclotron waves. going to slow down time right there for a second and just reflect on how we can, as creators, how we can, as explorers and scientists, take what we're curious about, find novel ways to look at it, to listen to it, find ways to share that with the world. As I said earlier in that picture of just kind of me with the harmonica in the car seat, all of this is brought into being just because I really love sound, and I'm blessed. I feel very fortunate that sound has been a way for me to essentially just continue an education. Sound has been a vessel and a vehicle to continue to explore the natural world. And that, for me, is the promise of sonification. It's that we can take this stethoscope to the universe and that we can use our ears, which, the highest resolution spectral analysis tools that we have on our bodies, which are optimized for analyzing frequency spectra. And we can use them to celebrate these sounds, to share these sounds, to experience the world in a new way. And then we can do things like this, where we collaborate and we put new things out and into the world. And it's always very interesting to see what comes out of these types of collaborations. So with all of your projects, please definitely send things my way as you're creating them. I'll just play a little bit more of this.
Robert.
Oh, yes?
I think it's time to return to Earth.
Okay. Huh. I guess we're going to return to Earth then. Can we set a course for planet Earth current time?
Setting course.
All right. Bring up on screen.
On screen now.
So I'm going to go ahead and just close this out with a collaboration with the Institute of Noetic Sciences. So this is a piece where Edgar Mitchell, Apollo 14 astronaut, had gone out to the moon and come back, and he experienced what's called the overview effect. That's what we get when we're out in space and there's this sort of expansion of awareness, expansion of consciousness, when something about looking down at the Earth and just seeing that there really aren't any divisions, there aren't any lines, something about seeing the vast field of stars and just kind of knowing that we're all stardust tends to cause this shift in awareness for many people. And so IONS was curious about, can we utilize immersive media to help to create this shift? So what we're looking at here is actually, it's a kind of recording of a VR experience. So this is on Steam VR, MetaQuest. If you have a headset, you can download this and have this experience. And why I'm sharing it today, there's underlying solar audio, so that rumble that I played earlier, that's the solar wind velocity measurement. And I've used that so many times just to create that feeling of floating out in space, because yeah, there isn't really sound as we know it in space, and yet there are certainly vibrations. The electromagnetic spectrum is filled with resonances and vibrations being studied by people like, Dr. Michael Hartinger here from the HARP team, and all of the rest of us. And so I just want to close out this share today with this piece where we're overlaying Audified data with a musical composition and the voice of Ed Mitchell, Apollo 14 astronaut. Let's play that now.
Ask politely.
Sorry. Play that now, please.
Confirmed.
The spirit within us is the guiding force that makes mankind great. For Earth to survive as a planet, we, humankind, must rise to the challenge of learning to be stewards to Earth and to each other. We no longer can follow the patterns of the generations before. Who believed because we were few in number, and the Earth was so large that its resources would last forever. Who believed, and we still believe, that conquest creates conformity and threat produces peace. We function like 12-cylinder engines, operating on only one cylinder because we do not know what we are. We are limited only by what we believe about ourselves. When we change our belief, we will see ourselves differently. We often say, seeing is believing, when precisely the opposite is true. Believing is seeing. To become the creative, intelligent, loving creatures of the universe, that is our true reality.
And that whole experience is about 9 minutes long. If you want to go and find that on Steam and try that out, there's also full recordings online. But I will go ahead and wrap it up there. It's been such a pleasure and honor to present and share with you all. So thank you all today. I actually couldn't see the chat as I was talking. I saw that there were things coming through, so I haven't read any of the questions yet, but I can go ahead and stop my share now.
Well, thanks, Robert. And I am really glad that you kept going while Glass Education had a little internet meltdown over here. So we are glad everything kept moving. So my theory that if I drive 6 hours south of my summer hangout, I would be safe from internet interruptions. But that was wonderful. And I saw some things coming in here. Let's see what we've got over in chat. Just some shout outs for your presentation, and but we'll open it up for some questions here. There was quite a lot, and I thought you did a really nice job of helping to explain the difference between onification and sonification, or the refinement of sonification as onification as a definition. That was nicely done. I really appreciate that. I struggle with that quite a lot. So other
Been doing it for a while.
Comments and questions? Okay.
Yeah, I got a question.
Shoot.
And I realize as I watch your presentation, I'm pretty sure I've cited you before with the solar wind stuff.
Nice.
But the data that you showed from SDO, I recognize the AIA wavelengths, but what was the underlying data that was codified in that case?
We're taking PSP, the close recordings of the encounters with the sun, and then I'm filtering based on the visual spectrum. So it's kind of like using audification as a driver, and then the visual recordings of SDO as a complex filter. The final iteration, I'd mentioned that this one had 200 channels of audio. The final version is going to have around 1900 channels that then get summed down to like stereo. Because the final version, we're going to take into consideration what elements, like what charge states of carbon are present at different wavelengths. And then we're going to actually use the audification of those measurements to then seed the audio that gets driven through the filter. So it'll be a little bit more true to the actual data itself.
Interesting. So it started with the Parker Solar Probe was the data.
It's a mix, yeah. So we're doing a little mixing and matching. Quite often, I think like when I did that X-class solar flare with the project, it took somewhat of a similar approach where we're doing a decomposition of the visual spectrum where high is high frequency, low is low frequency. The left is the left ear, the right is the right ear. And then I paired that with audification and then layered the two on top of one another. So I always like to explore what happens when we're taking different ways of representing the data and kind of like mix them and match them. And I'm always just trying to find like what feels like it's packing in the most useful information. And then I do try to do a good job of explaining like what is the core information that we're listening to here, because we can't just say like this is the sound of the sun, because it's the sound of a measurement that was taken of an aspect of the sun by an instrument
Plus
that
some
may have
filtering.
biases plus some filtering. Yeah. And so what I'm always trying to do is like I give myself somewhat of the aesthetic license when it comes to thinking about how can we take the information that we have and sort of distill it down to an auditory representation in such a way that it is providing with some like maximum amount of information. So that, that is to say like the ability to actually listen to features rotating around the surface of the sun, which we haven't really been able to do before through the means of direct audification.
Nice.
Thanks. And I look
Great.
forward to connecting with you more. Adrian has a hand up.
Definitely.
I do. Yeah, this was really, really fascinating. There's so many examples, so it's a lot to like
I know.
process. I was just watching a program the other day about Leonardo da Vinci, and when you said something about the sound as a vessel and vehicle to explore the natural world, I jotted that down because it seems to me that's what he was doing more in a visual way and with text and with his sketching, and you're adding this layer of kind of auditory audio notebooks as a way to explore. So I think it would be interesting to look more at those sort of connections, as well as sound as another way to journal, another way to notebook in a sense. But I did have a question, which was how do these collaborations come about? How do you work with these musicians? How do you find them, or do they find you? Because it's just really great to have those sort of creative collaborations.
Yeah. Well, it's kind of funny because when I look back, there are a lot of things that make sense retroactively, and yet quite often some of my most fruitful collaborations might start out as just like an email in my inbox. So literally that the whole thing with Jake and the Golden Hour and the film festival, there's just this mess. They had reached out to me because they were aware of the work, and I'd been doing it for a while. I think that helped, that I've kind of been solar sonification guy for more than a decade now. And so I've, literally had just people say, we typed sound of sun into Google, and I was just one of the first things that came up and they reached out. So that's one thing. I think also I do like with my YouTube page, it's that interesting kind of dance, whereas I'm working with colleagues and collaborators at NASA, I can't just put everything out because then you can't publish things, or we want to think about kind of what goes out there. But I do like when I find really interesting things, I'll just like put it out on my YouTube. So there's just lots of examples over the years of just different sonified solar phenomena. And yeah, just keep putting stuff out there. Oh,
Great,
and then
thank you.
one other thing that came to mind was I often will talk about the quote from Marshall McLuhan where he talks about the shoes as the extension of the foot. And it's like, glasses, the extension of the eye. And so thinking about how the, satellite can be also the extension of the eye, and about how we're using sonification to pull everything into the visual or the auditory modality. That's a quote I like to use as well. Thanks.
Thank you.
Yeah. Fia.
Yeah, just a quick thing. It reminded me of when way back in high school, I studied Greek and Latin, and we spoke about Plato, who has this idea of the planets making sounds, and like snares, they have the strings where they play these different kind of timbres. And I thought he was right after all, seeing your thing.
When we think about the harmonic relationship between planetary orbits, we can get a lot of really beautiful sort of spirograph images that just look inherently very captivating. But then also when we map those to musical intervals, which is something I've played around with, I imagine many of us on this call have, a lot of interesting things can come out of that, because now, we can mix the parameter mapping space where we think about like, what's the timing of this orbit? What's the distance from the sun? So doing things like take the distance from the sun, and that can be a musical node. And then the timing is like the timing of the event gives you a sort of musical cacophonous sound. But now there's more resources that are coming online that are helping us to more quickly get more information to represent various celestial bodies. And so we can create just more rich, dynamic modifications, sonifications.
Robert, I was wondering, you had quite a few things there where the visual component added a lot to that. In your future work, do you have some way, are you considering other like tactiles or haptics or other ways so that that information is available to people with no vision?
For that project that I was just citing at the end there with the AIA, where we're working with the various wavelengths, that is one where I want to, like for the iteration that I put out in the world, the next iteration that goes out, to have a combination that's just enough of the explanation around what's happening with each of the layers so that you can close your eyes and then you can kind of hear each layer of the sun unpeeling itself, and to first step through layer by layer and provide that description of, so this is what, the 320 angstroms sounds like. This is why it sounds this way. When you're hearing the sound emerge, this is what it represents. And then to step through each of the 9 layers before just playing back all of the sounds together. And with something like Breathscape, we have a table that we've built that's a vibrotactile table that you can lie on. So it would be very beautiful actually to lie on a vibrotactile actuated table and to experience that and just the sounds, the many layers of the sun. And I'll continue to think of more ways as well. Sitting in front of this flower and seeing the flowers on your screen, I'm wondering what the sun smells like.
Well, there were a lot of information was coming across, and it had in the times you did insert some explanation was helpful. But gosh, especially the multi-wavelength stuff that's coming through, that pattern, I think there's some interesting applications there that we could look at.
Yeah, and that's the one. So currently it's just utilizing one audio source for all of those different layers in that version that you just saw. And so then what I'm building out now is that each layer has its unique source. And then the richness of the audio will start to match the richness of the visual more, is the goal for that one. But yeah, the visual is very rich for that one, certainly.
Yeah, very good. Other questions?
Hey there. I don't really have a question. I just wanted to say your presentation was such a ride and so engrossing. And as someone who's given presentations on, maybe a very small segment of which you just broadly explained, I'm just inspired by the way you're able to connect both the kind of like a shared general understanding to, citizen scientists, and also to, put little seeds of the deeper information in there. So I just wanted to say I enjoyed your presentation, even this slowing down the video and the music and speeding it back up rather than just hard cuts and stops. I know this is all like minutia, but I feel like it helps connect us to an idea of deeper meaning in sound, rather than sound and media, visual media, as like these just assets that we throw on and off and use just to illustrate some sort of like more abstract, more important understanding, rather than like something that's very human and sensory based. So anyway, just really enjoyed that. I thought it was fantastic.
I so appreciate that reflection. Thank you so much, Seth. And early on, I talked about how with data audification, then we could start to utilize some of the tools that DJs use. And so I always do think it's fun when I'm slowing down the data that it feels like I'm actually kind of grabbing a record and like, ear, which is just such a fun gesture. And so that, you kind of said it's the minutia. I don't remember what word you used. I don't know if this will come through with my kind of background filtering. I got this whole kind of iPad that I put together, and it's got like all of the cues and all of the controls, and I really built it to feel like a musical instrument. And right up until like the hour before the talk, I was still having ideas and just kind of adding things in and thinking like, does this feel natural? And so for me, it felt like a kind of a improvisation meets science talk, and the interface allowed it to be a little bit more flexible. And under the hood, I'm using a software called Max MSP that enables the like video to be synced with the audio and for both of them to slow down at the same time. And so, yeah,
Then you can probably use our stuff directly. That's the same as Pure Data, isn't it, Seth?
Well, we've ported it to Max. Yeah, absolutely. You could.
And speaking of
you
which, you were
could.
just talking about Seth wrote a program where you can like put Tones of the Sun on piano keys on a touchscreen keyboard. Like you can get that on our website right now.
let's jump on a call, you guys, for sure.
Yeah.
Absolutely.
Okay, for sure. But yeah, anyway, your presentation, the style of it was something to be that I desire to do as well. So it's awesome.
Mhm. Yeah, when you say that you're the one who comes up with Googling sound of the sun, we envy that. That's what we aspire to.
Oh,
I'm not often wowed by presentations nowadays, but the amount of work that went into that, the way it communicates at so many different levels. And bottom line is I have joy in my heart from that. So thank you.
Yeah, as I was putting it together, I just had many moments of just kind of like reflecting on various projects that I've been involved in. It just kind of felt like a lot of gratitude, and I felt, I don't know if it like came across, but I felt so much excitement to like just be able to kind of like really properly geek out, and it was just a lot of fun for me. So thank you all so much.
It was a really great way to end up our first year of first 9 months of GeoSonNet. And Ranger here on the floor has decided that my meeting time should be over. And I did take him for a walk before this meeting, but I do want to, go back to the agenda just briefly here and let you know that we are going to be looking at a couple of different things to adjust where we're going with this project in the coming year. The original intent was we all get together, we find projects that we can enhance, or we track the projects that are currently happening. We enhance them with additional resources in terms of the topics that we've learned are important over the last few years with Sonification World Chat. And then you guys would be looking for your own funding that we can support getting those proposals written through creation of other resources and lit reviews and things like that. However, given the state of things, we have decided the first thing we're going to do is the Everett Group is going to be producing a survey that we're going to send out to the 40 some odd unique attendees to this GeoSonNet since January, and kind of parse out some information and see if there's some directions or some things that how can we adjust what we're doing for the times. And also I think that trying our hand at creating white papers that then in groups that you can then give to me, that I have something specific to go hunting for opportunities for. So I'm going to step into more of the role of helping find, see what we can find in terms of possible funding sources for specific projects. So I want to, since we don't have the time to really have a good conversation about that, I'd like to send out something for within the next 3 weeks, send out and have some meetings about specific topics. So what I want people to do is think about how can we put together a white paper with ideas that could be funded, and the criteria for this particular GeoSonNet project is that we want them to be multidisciplinary teams. We want them to include at least one blind or low vision professional. It doesn't have to be, it has as a tester, whether that person is a coder, musician, data analyst, whatever, but somebody on that team needs to have that background, lived experience. We would like to see them have music, the data scientist, or the neuroacoustics, or the cultural aspects of sound processing. So we want to think about who could you bring together, meet, and see if we can get some just one-pager descriptions of those. That will give me some place to go shopping, something to go shopping with. And that's my next best hope for what we can do, because our original plan to be having by now our NSF officers on to talk to us isn't going to happen right now. So we want to move forward, and we've got so many positive, interesting things happening. And I think it's time to keep moving forward with sonification. So with that, that's in the agenda. So we have a proposal that is to kind of adjust for objective 3 for our project, which is to document the current status of data sonification projects and emerging project needs to support the development of new funding proposals. So instead of going that way, we're going to try and adjust to doing the white paper idea. And I would take some feedback on that now. And then we, the Learn group is definitely a prime target for that. And I would like to support Fia and Adrian and whoever from the Learn group to get that group together and look at what kind of educational projects could be of value and possibly be sources of funding. So, or motivated fundings to get funding. All right. So with that, comments or questions on that, but do know that I intend to send out something, start getting these meetings together.
Yeah,
Okay,
I
so
just wanted to mention I just want to mention something quick. I put in the chat very early on a link to a poster that I found online not too long ago when I was doing some research. It's from the Geological Society of London, and it's all about geosciences, and it links a lot, like maybe 30 different geosciences or more, to specific proposals as part of the United Nations Sustainable Development Goals. And some on the call may be familiar with that. It's a set of 17 different goals, including things like clean water and quality education and partnerships. And there are a lot of other goals. I don't know if there is funding for SDG related projects, but when I saw this poster, I thought, wow, that would be a great tool to at least make sure this group knows about, because it has so many different geosciences plus a list of one or more of those SDGs, and that could be useful for developing educational projects and outreach projects, as well as research and development. So again, if you just go to Geologic Society of London, their geosciences poster, but that's also in the chat, and so hopefully Kate can get it to you folks otherwise, because I thought that was a great tool. It's available in English and 27 other languages, and hopefully available for people to access with screen readers. But that part I don't know about. Someone will have to let us know about that.
Thank you, Adrian. Okay. Any other thoughts and comments before we sign off?
I just saw that request from Fia for the link to the Ed Mitchell piece. So I'm going to send that right now in the group chat. That's a link to the Steam store. So if anyone has a VR headset, that can be downloaded from there. And then the first video on that page is just kind of like a playthrough that has the whole piece on it, the whole 9-minute piece.
Perfect. Thank you.
Yeah. I'm feeling a lot of joy as well.
Thanks again, Robert.
Yeah, thanks, Robert. That was a great great summer break. Okay. I'm signing off. Everyone
Yep.
take care.
Thanks,
Awesome to
Kate,
meet you
for all your
guys.
work.
Thank you.
Bye.
Thanks, everyone.
Bye.
Bye-bye.